Good evening, everyone. Let's start. So the plan for tonight is to look into an issue that has been open for a while in PyPy, which is this one. I mean, the actual issue isn't that old, but the problem has been there since PyPy started having a Python 3 version, and it's basically this one: imports not properly cached under PyPy3, which isn't, I mean, the title isn't entirely correct, but that's definitely what it feels like. Basically, the reporter observed the following problem: when you have a function that imports a module locally, like this one, and then you run that in a loop, then it will get faster under PyPy2. So in PyPy2, this function takes basically 0 time. It's extremely fast. And on PyPy3, this speed up doesn't really happen. And it's a big difference, right? It's like a couple of orders of magnitude. And let's actually try to run this very quickly to make sure that it still occurs. Hi, Julian, good to see you. No, that's wrong. Somewhere here. No, not here. Here. So something like this. Let's try PyPy import bench, Python import bench, PyPy3 import bench, and that's the slow one, and Python 3 import bench is fast. Right, so what, I mean, yeah, you can kind of see the problem. So there's basically a huge performance regression from PyPy2 to PyPy3, which is that importing a local import got hundreds of times slower. Let's actually compute how much slower it got. This is not very serious benchmarking, but let's do it anyway. It got like 200 times slower. And on CPython, from CPython 2 to CPython 3, local imports got a little bit faster, but yeah. And the other real problem is that PyPy is oops, yeah, S is wrong. PyPy is 7 times. PyPy3 is 7 times slower at CPython 3 at importing things locally. Right. So what I did when what Matti did when, or one of us did, was find out that CPython has a fix for that. No, I mean, let's start even earlier. So the reason why there is a difference between Python 2 and Python 3 is that the implementation of importing changed completely between Python 2 and Python 3. In CPython 2, importing was implemented in C, and given that importing is a really complex beast, in Python 3 it was decided that it would be cool to re-implement importing completely in pure Python, and that's the library called importlib, which is very nice from many points of view because it's just Python code and not this huge convoluted C mess. But it has the problem that, of course, given that it's Python, local imports always run some Python code and quite a bit of it, and so that's bound to be slow. And it was slow, and basically CPython had in 2014, they had the same kind of benchmark, the same observation, doing some kind of benchmarking here, and then they said, okay, what do we want to do about it? And what they did about it is this patch here. It's so old that it still happened when CPython was running on Mercurial, and what the patch does is the following: now already imported modules is up to 2.5 times faster. So how did they do that? The approach basically is to port back some of the code of importlib back from CPython back to C, and have a kind of fast path for importing written in C, and that should still use the importlib that's written in Python for most cases, but specifically for the case where you're re-importing something that was already imported, usually within a local function, usually locally within a function, then you definitely want to use this fastpath in C. And how the fastpath actually works, we don't need to read the diff. The diff is not that readable, but we'll look at the C code of that in C Python. Okay, so let's dive in. Oops, no, that's wrong. Here, right. So basically, if you look at the import name bytecode, which is the let's actually disassemble things here to figure out which bytecodes are used. What was it called? The function smuggler. So import this dot smuggler. What does the function actually do? It has an import name datetime and then a store fast datetime, and then it returns none. Right. So basically, the opcode that we want to make faster is the import name opcode. So let's go and look at how CPython's import name opcode is implemented. And so we open ceval.c, and here's the import name bytecode implementation, and it pops two things. It gets a name, it pops two things, and then it calls an import name helper function that takes a t-state, the frame, the name, the from list, which is from the stack, and the level, which is from the stack. And the name is from the co-names list out of the code object. Okay, so what does import name do? Right, and this is the C fastpath that we talked about. So what that does is, the first thing that we need to do here is we need to be very careful, because it's possible to actually change the global name __ import. So if you do something like def import star args return 17, 12, and then you say import datetime, then datetime is actually, maybe not. I thought that's how it worked. Maybe that's not true. Maybe it reads it from built-ins. Built-ins dot import. Does that work? Right. So this is one of the amazing dynamic features of Python. If you change the __ import built-in, then from then on, all the imports will call that function. Right? And by default, it's the import function __ import function from importlib, but you're perfectly free to change it to do whatever. So now we can import arbitrary names, and they will all turn into 12. Excellent. So that's the first thing that the implementation in ceval does. It says it reads import from the built-ins, and if there's no import function, then we get some kind of import error, import not found. And then there's a fastpath, and the fastpath checks whether is the import function that I'm getting from the built-ins, is that import function actually the same as the import built-in function? And if that's the case, then we can call this fastpath here, and if not, then we will just call import func from built-ins. And this would, this path down here would basically be the path that's taken in this case, where we've overwritten __ import to do strange things, and then this is the code down here. And basically in PyPy we will have to do the same. We should look up import in the built-ins and check whether it's some predefined thing and like the normal regular import function. If it is, we call our fastpath, and if it's not, then we just call whatever is found there. So that's the first thing we need to do. And then how this fast implementation in C is actually implemented, that's the second question. We'll get to that afterwards, but let's maybe start by saying, by distinguishing these two cases. And for that we go, where's my window? Here. We go here. So I opened pyopcode.interpreter/pyopcode.py, which is the Python version of basically it's the equivalent of ceval.c. It contains the implementation of all the opcodes. And here's the import name opcode, and we can basically look what it does. It should be kind of similar to what import name does in CPython. First, we get a name from using the name index from the code object. Then we unwrap it, whatever that means. Then we pop something from the stack. We pop the stack from the flag from the stack, and then we check that it's an int. Okay. And then we read the __ import, and if it's there, if it's not there, we say import not found. So this part is basically completely equivalent to what we see in CPython. And then we do something strange with locals. Interesting. Yeah. I don't know what that is for. What are locals even used for? I didn't see that in the CPython code. What exactly are the arguments to import? The arguments are, right, so here, that's the equivalent code. So the arguments are the name, the globals, the locals of the frame, and if there are no locals, then we pass none, and the from list and the level, right? So I think we pass the same arguments here. The name, the globals, the locals, the from list, and what about the flags? What happens with the flags? Ah, that's level, right? I think that's level. Yes. So we pass the level. Right. The last argument is the level. Okay, excellent. Right. So what we want to do now is we want to add this fast path. We want to add the fast path that says, please give me, yeah. We want to check, is the import that we're finding from the built-ins here, is that the same thing as the completely regular __ import that basically we have at the startup of the interpreter. And there are various ways to do it, but what we usually do in PyPy is we use some kind of cache. We use a cache that's filled at, let's look again what CPython does. What CPython does is it stores the normal import in the T state, right? So we have the T state here, the thread state, and we store the normal import in the interpreter reachable from the thread state as import func, right? So we can look at the diff and check how import func is set, right? So the Py state, the interpreter state, gets a new thing called the import func, and it's set here. It's used here. Where is it set? Let's use some more. Right. It's set in PyLifecycle.py. When we start up the interpreter, we basically right after startup, we read from the built-ins the __ import and store it in there. And PyPy does this slightly differently. I mean, we could do the same. We could store it somewhere on the equivalent of the thread state, something like the execution context or so. But we don't want to do that. What we usually do is we use some kind of cache, and caches are filled at bootstrapping time, basically. At the time when we translate stuff to C, we will fill those caches. So we would say something like, it's a bit of a weird API, but I will explain in a moment how it works. And then here we can say if we w default import then here is the fast path, right? And then else, there should be a return here somewhere. somehow. So self dot push value the object return, and the object comes from import fast path or import with arguments that we need to think about. Right. So that's the general shape of things, right? So now we need to figure out a number of cases. We need to figure out what this weird line here means. How does the import cache work? And then we need to figure out what arguments to pass here. And then we need to implement this function, right? So, okay, how do we do this? I'm also not entirely sure where these two things live. Do they live here in this function file here? Or should they be in somewhere in module imp, for example? Does that still exist? It does. What does it contain? Is there still... Right. There's still a bit of stuff. So this is, I mean, the imp module is where the full importing implementation used to live in Python 2, and there's still a few bits that live here in Python 3, but not a lot of them, right? Yeah. Before we look here some more, it's also kind of instructive to look into the import lib implementation for a couple of minutes. So import lib is part of CPython standard library, and PyPy basically copies most of the standard library, and it does a very small amount of changes to that. But usually it's I mean, it's basically a small patch set on top, but most of it is directly taken from CPython. And in there, in import lib / bootstrap.py, you have the implementation of __ import. And this __ import is basically the default import that we get when we just start a completely regular interpreter. I think you can see that if you start a Python 3 and you ask what is import. I'm not completely sure why it's a built-in function import. Right. And here, right. So I think it's patched in slightly weird ways to look at. Yeah, to look a little bit weird. For example, I'm not entirely sure whether you can use the debugger to step into it either. But it's really a Python function, right? You can disassemble it. Or not. Maybe there's fancy stuff going on to make it appear like it's a relatively built-in regular function, but it's really not. It's really this function here. And then there's basically a weird amount of bootstrapping going on here. Right. I don't really know the full details of how it's patched into the interpreter in CPython either, but right. Okay. Yeah, I think there's some importing. I mean, there's a circularity problem. What happens if the import machinery needs to import something, right? That's kind of the big question. And I think that happens in import lib setup. Oh, where's that? Right. Right, and you do that by having a weird bootstrap module that is there to basically give the import machinery some of the things that it needs. So the import machinery needs access to the sys module, to the _imp module, and to _bootstrap, and it reads these out of a bootstrap module. Right. And then it bootstraps some built-ins. And right. And it gets the OS module somewhere and stuff like that, and the thread module and the underscore weakref module. Right. Complicated. Yeah, as I said, I don't know the full details here, but it's okay. So let's try to find out a little bit more. Where does PyPy actually do this stuff? So module, and it has to be in built-in somewhere, right? So here in built-in, there needs to be this kind of thing, right? So here in built-in, we have an underscore import definition that is module importing import hook. So let's open this file, module importing, and then what's def import hook here? Right, and I think the way that the way it works is we have this very minimal thing, and this minimal thing is used to bootstrap the import lib. So this minimal thing is able to import sys modules, built-in modules like sys and OS and stuff like that. Not OS, but POSIX. And then after it did that, it will be patched by overriding underscore import with like overriding this implementation with the real implementation from the import lib. And we need to find out where that bootstrapping happens. Hi Tobias, good to see you. Right, so let me try to, I think it's probably instructive to grab for this string. Right, there's a lot of it. Maybe here. There's tests, there's zip import, weird things. There's something called frozen import lib that could also be interesting. So what does that do? Thanks. What Tobias is referring to is the fact that I got vaccinated yesterday, which is still a little bit rare in Germany, but all university employees are able to get shots now. Right. Right. So I think this is the code. So we have the frozen import lib module. And that says on startup, we will get the built-ins and then say set dict value, don't introduce cell. That's slightly weird. What this API is for, but there's a good reason for it. And then we override the bootstrapping underscore import with the real underscore import. Right. So who imports this frozen import lib thing? Interpreter module, interesting. There's another one here. I think those are the two promising ones. Right. So here's a setup function, and that's basically done at some point. That says setup self get built-in module, and that has a side effect of doing things, of setting the import correctly, I think. Tab new interpreter module. Right. This looks less relevant. Basically, we need a frozen import lib also to yeah, the wrapper of modules is also implemented in Python, and it's also available via the frozen import lib module. So we get the built-in module frozen import lib, and then we read the module wrapper function out of there, and then we call that in order to be able to compute the wrapper of a module. Let's actually look at the implementation of that. Here, module wrapper, right. The implementation of module type underscore wrapper. Okay, so I think we have a bit of an idea what's happening now. Right, this is the object space. Okay, so I think we will do this slightly differently. What we will do is when we were here. When we do this overriding of the built-in underscore import with the real bootstrapped import lib import, then we will also put this function into a reachable spot. And that reachable spot is going to be the space. W default import lib import equals self.w import. The space is this slightly weirdly named API that we have available basically everywhere in the PyPy interpreter, and the space is basically some kind of API object that allows us to do operations on all kinds of Python objects. And it's a useful place to put this because we should have a space here. Right? We have a space here. It's a space. It's called. I mean, the more officially the thing is called an object space. So. And we can say, let's make a comment. What's the function called? The function is called startup. Okay. So now we have the default import, and we can compare it to the import that we have. And if we have a fast path, yeah, we do something. And then, yeah, I'm not entirely sure where this goes, but I think it probably should go to the imp module. So we should say from pypy.module.imp.importing import name fast path. Right. So that's good. Importing is here. Let's put it here somewhere. So now the big question is, what are the arguments? Right, and I mean, the arguments is one thing, and then the next problem is the implementation. But let's start with the arguments. Right, so we can look at the C code again. What arguments does so this is basically the equivalent of this, right? By import module level object, and that gets a name and globals and locals and from list and level. So let's start with that. It gets right. I think it's going to be pretty similar to the arguments down here. And so it gets module name and globals and locals and from list and flag. Right, roughly like this. And then now we might have to move these lines of code down a little bit. Because we want to do that after we computed. Wow, okay, there's some definite nonsense happening here. So this is slow already for other reasons. But yeah, I think the fast path goes here. So okay. Right. Okay, yes, that looks plausible. And the thing that I was saying earlier is we do this wrapping and unwrapping thing here. So here we have a wrapped text object, and then we unwrap it into an RPython string, and then we rewrap it down here. That is inefficient. We should just not do that. And I think we can just, do we use this? The only place we use this for is for rewrapping it. So I think we can just delete those two lines, right? Yes, this is very weird. Delete, delete. Right, that looks good. So it's immediately faster. Okay, so now we need to think what we actually want to do here. So, okay. Does it take a space? I suspect it takes a space. And does it take a frame? This one doesn't take a frame, so it probably doesn't take a frame. But a space is always a good idea to pass. Right, so that's our definition. Right. It's a bit too long. I'm going to call it levels. Right. Right, so and basically one extremely simple thing to do is let me check something. We should always, like, a valid implementation of the fast path. Ah, yeah, right. Tobias asks why we don't check whether something is in sys.module 0. We can't check that easily. So, but CPython doesn't do that either, right? So CPython also does the fast path if the import function is the expected import function, we call the fast path. And then in there are going to be further checks. So this one is in, I don't actually know. Wait. Let's find the thing. Yeah, I said so in the comment, that's right. It's in Python import.c. I expect there to be a comment like this here somewhere. The below code is imported _ import and GCD import ported to C for added performance. So is it really true that maybe they don't do that? Maybe they don't do this fast path at all. I'm not sure. I basically expected there to be some checks here, and then if those checks are wrong, I expected this code to call back into import lib. That doesn't seem to be happened that much. I mean, we can grep for import lib. Right. There's definitely some calling into import lib here. Magic number. What is that? Find and load. Yeah, I'm getting lost. I mean, this C code is scary. But yeah, that's maybe the comment is just wrong, and it's doing this differently than I thought. So I mean, basically, what I thought it would do is I thought it would just check whether it's already in system.models. If yes, return it. If no, just call the existing import lib. But it seems that's not what's happening. It seems there's really more C code here. Right. Resolve name. Package complicated things. This is a lot of code. Right. Import get module. So where's that? No, but that's not what yeah. I'm scared by this stuff. But it's recursive too, right? We have this PyImport import module level object, and we call that recursively. Okay, so we need to do this step by step. I mean, the first thing I want to do is I want to make sure that I haven't broken anything, and I can do that by saying it should be okay to still basically when I don't want to do any more work, I should be able to give up and say, okay, if I call the default thing here, it should still work, right? Then we use the fast path, and the fast path jumps back into the slow path, but that should be okay. Where did I write the comment? Okay, I'll delete that comment because I'm not sure it's true. But yeah, if I have this code, basically we check whether we can use the fast path, but then in the fast path we just do the slow thing again, then we should still, I mean, basically nothing should be wrong then. Let's try that. So if I run some tests now, let's just do this maybe. Good. Well, not good, but right. That's not good. Okay, so what's happening here? I suspect we can put a PDB here. We have a bootstrapping problem. We already run some Python code before we reach the code that sets this attribute, right? So that's where we are. We don't even find the attribute. So we can actually find out where we are, right? We run some global, in order to load some stuff from the sys module, we need to run a global, basically the whole module of something in the sys module. So we need to be able to deal with the fact that this thing doesn't exist, or we should set it to none, right? So we can in here we can set the attribute of that to none. Or maybe let's be nice and do it here. Right. And then in the fast path, we need to make sure that if this is true, if this is none, then we haven't even set up anything. So then we shouldn't take the fast path. Okay, we need a new line. Right. Yeah, it's kind of weird that we are able to run some Python code, like to import stuff that's written in Python before the import lib thing is there yet. But yeah, I mean, PyPy really has some extra complications in the bootstrapping process because we because of the fact that we really write a lot of core functionality in completely regular Python, not even RPython, just completely regular Python functions. And part of these completely regular Python functions actually are in the sys module. So in order to even construct the sys module, we're going to have to run some Python code. And yeah, I think when we first started working on PyPy3, there was actually quite some complications around this fact. Right, and as usual, the PyPy3 tests while I'm streaming take a bit forever. But at least it doesn't, it explodes less immediately. So, okay, things pass, that's great, that's great. I mean, it doesn't even really matter that much which test I run. It's just in order to even bring up the interpreter, this stuff cannot be completely broken, so that's good. And that's really all I'm going for here. So lack of complete brokenness. Okay, so now we need to do some actual work, and the actual work basically consists of taking this code here and writing a Python version, an RPython version of that. Right, and I think this is really the, this is really the important bit, right? So copy that. And then I think, let's assume that the comment is actually true, which might not be the case, right? But let's assume that it's true. And if that is true, it might be easier to actually look into what import lib does, right? Because, the C code is Python code ported to C. And instead of porting that back to RPython, it might actually be easier to port the original Python source to RPython. So that's what I'm going to try. Right. The locals argument is ignored. Great, great. Right. Right, and basically we should feel free to do less work than CPython here. We can start by saying, okay, we wanna just support the we just want to support the level equals 0 case. Level equals 0 is we don't have a relative import like from ... package import mod. And given that, yeah, I think those imports are slightly rarer than just absolute imports. So maybe we want to deal only with this case for now. And we can. I mean, basically, whenever we are here, we can do, we have some conditions, and then we have some fast code and return. And if we don't want to import that stuff, we can always fall back to this case if we want. Okay. And I think, one candidate is definitely only dealing with level equals 0 for now. But I think CPython doesn't. CPython really does it all here. Where's the level? Oops. Off by 1 on the keyboard. Right. It does resolve name here. Right. Okay. Yeah, scary. I'm still quite out of my depth here. Let's read some Python code. Right. So first we get the module, and we do that by calling gcd import, either just with name or with package and a level, if the level is not equal to 0. And then we have, if we do not have a from list, then we return up to the first dot in name. Right. So there's some weird string manipulation, but it sounds again like the level equals 0 case is relatively simple. And then the from list is also complicated. So maybe let's start with that. Let's start with the case if the level is 0, and yeah, what does CPython do with the from list? Right. Right, but it looks to me like, so if we don't have a from list, there is code here, and else we will call handle from list from the import lib. So they're cheating here too. Basically, I mean cheating. They decided that some things don't need to be extra fast. So even their fast path has calls back into import lib, which is pure Python code. So we can do that too. Right. So I think my goal is to be to try to handle the level equals 0 case, and then not having a from list. Right. So okay. So we're going to have to do gcd import to implement that too. Right. There's a sanity check. Then we do resolve name if level equals 0, but we decided to have level to only handle level equals 0. So then there's find and load, and this is where the work happens, right? Okay, let's follow the C code some more. So there's resolve name. We won't do that. We have this, and then we have import get module, right? So what happens in here? I think I should really set a mark or something, because I keep getting lost in this file. Okay, I mean, this is the fast path that I was expecting. So the first thing we do here is we check whether the app's name is in sysmodules. This is what this function does. And if it's not null and not none, then we check that the module is initialized. And then we're done, right? Then we loaded the module. Otherwise, we need to do the real work, and then we do import find and load. And that's hard. Ah, right, but that calls back into import lib, right? So I was kind of right. So if the so lots of complicated stuff, but the basic strategy here is in the C code. We do some analysis of relative imports and so on, which we might even ignore in PyPy. But then what it boils down to is we check whether it's in sys.modules. If it's there, we use it. We check that it's initialized. That's also a little bit complicated. But if it's in sys.module and it's initialized, we can just use it. If that's not the case, then we just call the existing Python code in import lib. That's basically the accelerator that CPython uses. And I think we can steal this strategy in PyPy. So in PyPy we can do the same thing. We can say check sys.modules. If it's there, check that it's initialized. If it's initialized, return it. If it's not initialized, then we will just fall back to the import lib implementation. Right. So let me write that down as a comment. I'm not even sure if this comment is going to be correct, but the idea is check sys.modules if the module is already there and initialized, we can use it. Otherwise, fall back to import lib.import. So I think this is the general strategy, right? And yeah, that's not completely true. Let's delete the comment. So the first thing we need to do is we need to do some type checking here. We want to make sure that levels should be an integer. So we should say levels equals space.int. So this will convert the wrapped levels, which is a Py object, into an R Python level integer. It's like a C integer. And then we should say module name equal space.text w module name. And this looks somewhat inefficient again, but let's keep it for now. I'll add a comment. Right. And now we said let's start by handling only the case where levels equals to 0, right? That's the simpler case. Okay. So we get the module by. So the first step is we say we get the module by doing. I mean, in import lib it's gcd import name, and that the name is the module name, right? So this is the first step, and let's compare it. I'm not going to call the function gcd import, but just as a comment of what I'm trying to achieve, and then I'm a bit confused. So if level equals 0, then we get the module by calling gcd import. And then if we don't have a from list, that means it's not from blah 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 import abc, it's really just import math, for example. If we don't have a from list, then we call gcd import again. With if there's no dot, it's the same thing again. Why? That sounds inefficient. No, we weirded out by that. Why don't we, like, if there's no if there's no dot in the name, then partition will just return the full thing, right? And then we do the exact same call that we did up here already. And how can name be none here? So I'm also very unclear what this case here is for. Oops. Right, in this case we don't want to do because it means that level is not equal to 0. But right, I think I really need to focus on the fact that I really only want to do level equals 0. So I can ignore this case and this case completely. And I also want to ignore the from list being something that's not empty or not none. So here and space dot is true and not space dot is true. Is it is true or is underscore true? Right. Is underscore true. This is basically checking whether a Pi object is truthy. Right. And I think that's really the case that I want to do. No levels. So it's an absolute import and the from list is empty. Right. And in that case, I really I do the import and then I call GCD import and then I call GCD import again. And I haven't quite understood why it does this inefficient thing here, but let's just go with that for now. Right. So we want to do the right. Okay. Sorry, I'm getting a little bit lost. So I should actually let me rename that to name in order to match the right. And we know that level is equal to 0. So from my perspective, it really looks like this. And the thing that is a bit weird to me is the fact that why do I do the same call twice? I mean, if it says import a.b, it makes sense. Because then I first do import a.b, the full thing, and then I do an import a to find out what to put into the globals, like what to return. But what I don't understand, if there's no dot, why do we call GCD import again instead of just reusing module here? I mean, that part looks a little bit weird to me, but let's go with it. I think this is really what it reduces to. And now we need to find out how to do GCD import. So is it level or levels? It's level. We should be consistent with that too. Right. Okay, so what happens now? We need to be a bit careful. I think there is actually no partition in our Python, so we should write it slightly differently. So dot index equal name dot find dot, and if dot index minus equal -1, then we can just return the module, and else we return the GCD import of name up to the dot index. I mean, or we can be exactly compatible to what CPython does and do it like this. Okay, so now we need to do what GCD import does. And GCD import calls find and load. And find and load, what it will do is it gets a lock, then it checks sys.modules, and if it gets needs loading, then we reload it. And but if we have it in sys.module, then we check we check that we get something, and then we say lock unlock module, and this makes sure that it's initialized, and for that we get the module lock, we acquire it, and we release it. But the trick is that CPython does none of that, right? So if we go back to the C code, we don't see any of that. So what we see is that in CPython we where are we? Level equals 0, apps name, we say import get module, right? We say import get module, which reads sys.modules, and if we found something in sys.modules, so if that's not null and not none, then we do ensure initialized, and ensure initialized right. That has an optimization here. Only call bootstrap lock unlock module if _spec.initializing is true. Because of this, initializing must be set before stuffing the new module in sys.modules. So it uses basically a cheap check that just reads some attributes out of the module in order to not have to do the locking and unlocking, which is expensive. So what's the attribute that it's reading? _spec_initializing. So we should be able to find the code that sets this initializing, right? Right. Right. Aha. So we have this installed safely. With handler, and what we do with that is we say module from spec with installed safely module, and that sets initializing to true, and only then is it put into sys.modules, I think. Right here. We set initializing to true, then we put it into sys.modules, right? So that's our plan as well. Basically, our plan is we're going to check the spec and then the _initializing flag and see whether that's exists and is false, right? I think that's what the C code does. The C code right. What the C code does is it says PyModule spec is initializing, which we have to find. That's it. Objects, module object. Right. That gets the attribute initializing, and if checks whether that is true, and if it's true, it returns true. Otherwise, it returns false. Right. Okay. So yeah, let's try to I'm going to have to make the comments nice at the end, but I mean, this is really a lot of stuff and I'm getting completely lost. So I'm trying to write down some things in order to help me remember what I actually want to do. I'm writing the same thing as I wrote here, but now I can actually add the comment here. Okay, let's see. Can we actually, is this a completely regular attribute? So if I say something like import this, right, I have no clue. What is that? There's an import spec here. Where do they live? Oh no, it was called module spec, right? Right. Right. And in particular, it has this. Right. It has this initializing thing that's not set in its init, just to be annoying. Goodbye, Tobias. Nice to have seen you. See you next time. Right. Okay. We're fighting through this. Okay. I'm quite stressed out by the whole thing. Basically, all my interactions with the importing module, with the importing system, are always very stressful, and today is no exception. Right. So we do import get module. I don't know how to do that even. So how do we get the sys module? Right. Like this. Very good. And now we do, what does it do here? We do a get item, right? Like this, and this can raise, and we should check. I mean, we expect a key error here, right? So, and if it's not a key error, we will just let it escape. So if not, how do we do that? Match like this. And if it's a key error, we know that it's not there, and that means we cannot do anything, right? So then we are basically in this case where we do import find and load. And I think we checked already. Import find and load will call import lib find and load. Right. So here. Let's actually check that. Right. Yeah, okay. So GCD import basically calls find and load. Good. Calls find and load, passing itself as an argument. Interesting. Why ever that is needed. Okay, I don't get it. Okay, so right, I don't quite know how to do that yet, but let's put an XXX here. But if we find it in modules, right? Now we found the module. It was already in sys.modules. That's great. So now we need to check whether it's actually already, whether it's currently initializing or whether it's no longer initialized. And to do that, we should be able to say try space.getUtter module space.new text. We get the spec, right? And then we get the underscore initializing attribute. So initializing equals space dot get utter spec space dot new text initializing oops, and except this can also raise. Do we care if it raises? I think it should only raise if you do weird stuff, right? I think it raises only if you say del this dot spec, right? And then if you say import this, you get it back. No, I don't know. So I'm not really sure what we should do if we get an exception here. Unclear. Yeah, there should be no exception. Let me actually just, I'm going to let the exception escape, and then basically the caller can deal with the fact that they messed up the module that they're trying to import. Right, and now if initializing is true, then we are in the hard case. Otherwise, if it's not initializing, we have a perfectly usable module, and we can return that. Right. I think this is the plan. This is the plan. Let me read this again. So we turn the level into an integer. We turn the module name into an RPython string, and then we check. We have a fastpath only if the level is equal to 0 and the from list is not true. That means the from list is empty. If that's the case, we get the module by calling GCD import. And if there's a dot in there, we call GCD import again with the same name, which sounds weird, and I think the C code doesn't do it. But the Python code does, so let's keep it. And otherwise, we return GCD import of the prefix in front of the first dot, because the reason for that is if you write a.b, then what will land in your globals is actually a. You import both of them, but only a will land in your globals. Right. So that makes sense. So what does GCD import do? GCD import, according to the C code, it will read stuff from the modules. It will read this attribute from the module, from system modules. If there's a key error, if there's something that's not a key error, then we just raise that, because that means somebody patched sys.modules to be weird. Right. If we get a key error, then we need to think. We need to call find and load. Let's do that in a minute. But if we find it in sys.modules, we get the spec, we get the underscore initializing attribute, which should be set to false if the object is usable. So if it's true, we need to do something hard. But if it's not true, we can return this. So now let's fix those two places. where do we use the right? Okay, good. Here, get the import lib, and then what we do is we return the function. We call the function find and load from import lib with which arguments? Is it underscore find and load, or it's underscore find and load? And what are the arguments? The arguments are the absolute name, the import function, and null. Okay, this thing is annoying. What does that even mean? So let's look at the Python code. Find and load takes okay. Whatever you want, you weird import lib thing. Sorry. It takes a name and an import function, right? So we get a name, then I'm trying to edit this. We get the name, which is space.newTextName, and then we need to pass the import function, and the import function is space.getUtter wImportLib, comma GCD import. Right. I mean, this can be slow. This is slow code, but it can be slow code because it should be a slow path. Except that this needs to be space.newText. Right. Okay, good. Not entirely sure this works, but if I say import lib called this. Okay, that's a bit of a problem. What is in there? Is it import lib dot bootstrap? Yeah. Right, so we need to get it from another getUtter here. Right. Why does the C code not do that? I'm not sure. I'm not sure. Yes, I must say this isn't the most, I mean, I'm not really doing the most enjoyable task tonight, but I think it's really, I mean, it's kind of important because people really write local imports into performance relevant functions, and right. I hope this is right. I'm not entirely convinced. We will see a crash soon enough. Right. So what else? We need to do this, and this will look equally strange. So we were doing ensure initialized, and this does. It does the is initializing, which we did, and if it is busy, if it is initializing, then we can say import lib dot lock unlock module. Right. Let's try that. So if we are initializing, then we really need to lock and unlock the module. What it means is either we have a circular import going on, or some other thread is currently importing is currently importing this module that we're also trying to import. And then we should wait until the other thread is finished, and that's why we lock and unlock the module here. And so we should say this stuff, and then we say return space.call method on the import lib, and we call what? Lock unlock module. Right, and we call it with which arguments? Just the name, really? Let's look at the code here. Lock, unlock. Yeah, it's just the name. Right. So here we say space.new text name again. This is all very messy. We need to do quite a bit of cleanup here. I mean, we have the same. We have some copied lines, and we call new text on the name 3 times, and that's all. It's all not that great. Right. Actually, yeah. What do we do with the name here? The only thing we do with the name is we pass it into new text. So that's wrong. So we should just pass the name in wrapped form here, and then. So this wrapping and unwrapping thing is basically turning our Python strings into interpreter objects that represent strings and back. And wrapping and unwrapping costs a little bit of performance, so we should be able to, we should be careful to not do it too much. Right. So here we can say module name, and here we can say module name, and here we can say space.new text. Yes. Okay. So yes, maybe this is what we want. I'm not sure. I mean, now we should just run stuff and watch it explode horribly or something. Right. Okay. Boring problems. Space. We need a space. We always need a space. Frozen import lib has no attribute bootstrap. Right. Yeah, we are here. And we cannot get the underscore bootstrap attribute. So now we need to find out how to get this find and load. So if we do this, what's actually in there, right? I don't know. I don't even know how this works. We have a dict. Let's look into the dict. Module dict. So what does that have? A D storage X. Oops. Yeah, everything's in there. What's the problem? Lock unlock module and find and load. Okay, so we don't need the extra. We don't need the extra indirection. We don't need the. It's enough to use the import lib here. Wow, there's a nice thunderstorm outside. Actually, don't ask me why. Oops. Cool. We managed to call Okay. We got surprisingly far. I mean, we ran all this code up to here, including this whole mess, right? So I'm actually kind of optimistic that this isn't complete nonsense. But then, of course, we get stuff like that. Thank you very much. Right. Now this is frustrating. What's going on here? POSIX has no attribute stat result. So basically something goes very wrong. And I don't really know where. Ha. Right. So we're somewhere in the fast path. We're doing stuff in the fast path. We can go up in the debugger until we see that. Right. So we're here. We're running the fast path. We're trying. What are we trying to import? We're trying to import OS, and from list is none. And so it's literally just an import OS here. Right. So let's go down. So now we're in GCD import, and it's not in sys.modules yet. So we're trying to call final load. Right. And this is exactly, let me just say that this is exactly why I hate this stuff, right? Because now we get this completely bizarre import error somewhere deep in the bootstrap process of the interpreter. So we're trying to call import lib final load, and it should just do the right thing, but for some reason it doesn't. So what's the name? OS. And we get GCD import. I don't know. I wonder. I wonder whether we should do this even differently. Why do we even, like, we can do something even more, much more coarse-grained. I mean, I'm not going to commit this, but I'm going to try something. I'm going to have an exception class. And then whenever something weird happens, I call this thing. I raise such an exception, right? And then I'm not doing any of that. And if we're initializing it, I also say fastpath give up, right? And then here, around this, I put a try except. And if we get the exception, we just go back to just calling the regular underscore import. So no, I mean, I'm trying to be less clever. So before I said, okay, I managed to do the first half of this whole importing stuff, and it gave me a little bit of a result. And then I call into the precise point in import lib where I think I am. But if something goes wrong there, it's just it's kind of brittle because I'm really relying on a lot of details of the import lib. And now I'm doing something much more coarse-grained, which is that whenever something goes wrong, I just go back to this code, which I know works. Let's try it. And if that also doesn't work, then I don't know. Yeah, I get the same thing. Why? I'm still here, right? Who is trying to import POSIX? Right. No. Right. So I'm in the fast path. And I know that I'm importing OS, I bet. And level is 0. Right. And now I'm confused. Because the thing that we tried earlier that actually worked was when we didn't have any of that code, right? So if we just don't do any of that, then it should really work. So let's try to unwind some more. So now we're really not running anything different at all from now. Stuff should really work, otherwise I'm extremely confused. I mean, now there's basically really no new code at all. I just say if false, and then I call the default import lib import. And this better work, because otherwise yeah, the importing system is very big and complex, and no, this works. That's good. So then now I really don't know. Okay, let's try to catch this in a debugger. So if name equal OS, then let's start a debugger. Right. So we're importing the OS module somehow, and we're trying to use our fast path. So let's step in here. So we get the modules, and what are the modules? Oops, sorry. So those are the modules that we already know, right? We have some PyPy stuff, frozen import lib, imp, not a lot of modules, but there is POSIX, right? And so just out of curiosity, I mean, OS and POSIX are quite closely related, right? The OS module is basically a wrapper around either POSIX or some like NT something on Windows. So what OS does, it will import POSIX relatively quickly. So one question I have is the POSIX module, is that actually initialized? Oops. So I have a spec, and can I say underscore initializing? Right. So the POSIX module should just exist. Does it have a stat result? It doesn't. Why does it not have a stat result? Oh, oops, sorry. Yeah, sorry, this is not super fun. It's not fun for me either. Okay, so because now we're debugging something that really kind of has nothing to do with what we're trying to do. Right. Okay, so let's very briefly look at what does the OS module actually do. It's import stat. Does it import POSIX? Right, it does. Any new dependencies of the OS module and or changes in path separator requires updating import lib as well. Whatever that means. It sounds to me like OS is special. Actually, yeah, let's actually do something very weird. Let's try to see whether it's really only the OS module that's the problem, or whether other stuff is also completely broken. Because the OS module really is special. It's quite central to many things. So I mean, I don't want to commit that. I just want to sort of find out whether we have a real problem or whether the OS module is just very strange. No, we have a real problem. That's too bad. What happens if I run some tests that aren't from the... I'm grasping at straws here a little bit. It's possible that... Oops, yeah, I should. It's possible that I'm basically... I would be fine if I... Yeah, I don't know. Yeah, I'm always getting the same thing. I'm also in import name. Okay, let's go up. I'm somewhere in my fast path. Right, I'm somewhere in my fast path. And I'm trying to import future, and even importing future breaks stuff somehow. And alone the fact that I try to import it via this fast path breaks things. So that's a bit weird. So alone the fact that I'm touching stuff here somehow, yeah, breaks stuff. And I don't really get that. Because, I mean, the fast path here is really not, the fast path it's not writing anything, right? It's just reading, it's reading stuff out of a dict, it's reading a few attributes, and then it's just using the module. So I don't really understand why. Why we have a problem here. I wonder whether we can be even more, yeah, I don't know. I mean, in a sense, we're now trying to optimize something that we don't really care about. We don't care about the top level imports. Like, I mean, we're importing the future module here, right? So that's by definition, that's a top level import. So yeah, we don't really care about this case. Maybe we should make the fast path even more specialized and do that only if we're actually running a function object. right? And we can find that out. We can say, what are we running here? Right? We're running the global, global code object of some test. That makes sense. And so now I'm wondering whether we can say, let's do that only. Doesn't that have... what is it called? Co-flags or something? Co-flags, right? Let's do that. Let's try to reduce it even more. I mean, none of this is going to stay. It's just that I want to find out under which conditions if we do it in fewer and fewer cases, at which point does it actually start working? And I mean, co-optimized, right? So let's do the fast path only if we're actually importing stuff locally in a function and not on the global scope. And we can recognize a function by saying, do we use the optimized fast locals? So this is oops, here. This is a bit weird, but let's try this. So if our code object has a flag that is optimized, which means local names are stored in using fast, load fast and store fast, and we use the default importer, then do stuff. Let's try that. I mean, as I said, that's not really what I want to write, but I want to find out what's going on. It seems to fail less quickly. That's good, maybe. Aha, that's more interesting. So now we have a module that doesn't have an initializing attribute. Right? It fails differently. Success. So what thing are we importing? Sys. Sys doesn't have a spec. That makes some sense. Sys is special. So what does the C code do? So it's initializing. It does get utter, and if it's right, if it is not null, then we check whether it's true, and if it is null, then we just return saying that it's not initializing. So we can do that too. So here we say try and accept operation error as E, and if it's not an attribute error, we raise. No, and otherwise we return, we can say initializing is, no, it's fine, we can say else. Right. If we don't even have the attribute, it seems to be a special module that we can just assume is initialized. Okay, let's see. Yeah. I mean, I kind of expected already that this would be a bit of a terrible task, because anytime, I already said that like 3 times, but anytime I'm touching the importing system, I fail to be productive. And I mean, it's not like I touch it that often. Wow, cool. So that works. I don't know why, but that works. Let's run some tests here. Let's stop them. Let's check whether we can run the importing mock tests now. Good. So what did we do? What we did is we did the optimization in even fewer cases, and we do it only if it's done locally in a function, which isn't great, right? I mean, in theory, this is too narrow, right? I mean, we kind of don't want to leave that because I mean, you can definitely write weird code like this, right? You can write code like you can do that, and then it's not in a function. It's in a module, but yeah, I don't expect this kind of code to be that common. I mean, what's more common is really the thing that we do a bit everywhere too, right? So you really have a local import. Right. So those tests pass too. So let's wait for those, whether the importing tests pass, and if they do, we will just commit this. I mean, it's not really in perfect shape yet, but it doesn't explode completely, and yeah, and it's at least then we have a. I mean, I'm on a branch anyway. It's not like I'm committing this anywhere important. Then we have a known state where the fast path actually does something. Maybe it's not perfect yet, but right. Yeah, I mean, the whole bootstrapping process of bringing up the PyPy interpreter is really quite complicated. And there's actually like one of our oldest issues in the issue trackers saying, please clean it up, but it's at this point it's like 10 years old. Oh, interesting. Okay, that's a new, so we should deal with that. I mean, this makes sense, right? Somebody puts into modules a none, and then we try to read the spec, and it explodes, and we should catch that error. Right? So we should put that here. I'm not really sure. What does the test do? Let's look at the test. I'm getting a bit too many tabs here. It should raise an import error, it seems. Okay, what does the C code do? Module spec is initializing, we call that here. I'm not sure which code catches that. But I mean, I think what I want to do in my code is that if this raises, I'm just going to give up, right? Right. Okay. Yeah, the thing that I can do while we wait for the tests is I can actually start a bootstrap to see. This is not going to finish in the stream. It takes like 45 minutes or something. But it could fail quickly, and if it does, we want to do something. This is a bad test. This test is a very bad citizen because it stuffs something in sys.modules, but there's no finally that removes it again. So maybe you should actually add that. Okay, what do my tests do? Let's don't run. So why do we expect this code to be faster, right? I mean, we expect it to be faster for two reasons. One reason is that all that we're doing here is written in R-Python, which is compiled to C, which is which is hopefully faster than interpreting the Python code in the import lib. So that's one reason. The other reason is that we're going to JIT this, right? I mean, basically all the code in all the code that's in R-Python in the interpreter by default is kind of used by the JIT to produce machine code for the stuff that we're seeing here. So all this code here will be traced by the JIT. And the JIT is really, really good at optimizing stuff like sys.getModule, space.getItem on things. It will turn all these things into very small, a very small number of machine instructions. And hopefully, so one hope is indeed that it will turn this into very efficient machine code that just read stuff out of a module, out of sys.modules, which is free, that gets turned into no machine instructions, because we very carefully pick a representation for the sys.modules dictionary that is sort of works well with the JIT, and then we read the spec that should be free, because reading stuff out of a module globals is free basically, and then the only downside is that we have this module spec, and then we read the initializing thing out of there. So that's a bit annoying. We could do better here, because that is going to turn into some actual code. But if we wanted to, we can also try to improve that in the JIT later. But even then, it will turn into a small amount of instructions, hopefully. Okay, that works. Let's run it again with fail first. So then we'll run this failing thing first, which hopefully now passes. It does. And then we don't need to rerun all the others, I think. Right. So the translation to C is also chugging along. That's great. It didn't immediately explode. So that means we can think about committing. We stop doing this double unwrapping here. Yeah, then we have the fast path, which we only do in the function for annoying reasons. So this would definitely be something to fix before this ever gets merged or something. So then we store the default import lib import when we import lib. There are way too many import in that sentence. Then we have the fast path here, and we have a fast path only for a very reduced set of cases, only when the level is 0, like there's no relative import. The from list is empty, and I think the name not equal OS, we can probably stop now. Let's actually try that. So let's not do that anymore and try again to run the tests. Ah, it fails. Right. Okay, so two interesting things. We can wait for the tests, and while we wait for the tests, we can look at the bootstrap to C failure. So this is actually an RPython restriction. The code that we've written isn't RPython enough. And the reason is that slicing not proven to have non-negative stop. So we're doing this slicing of the name here in our fast path, and the stop is .index. But what the translation process is telling us is that the type inference couldn't prove that .index is not negative. And we can fix that by saying, instead of saying if the type inference doesn't know that it can be either -1 or something non-negative. The result of string.find. So we need to tell it. So we can say if .index smaller than 0, then we do this. Otherwise we do this. But now the translation process can figure out that .index must be non-negative in that path, right? Because we check for the negative case, we check here, and then we go here. But that means if we end up here, we're non-negative, and then we know that this is greater or equal to 0. This is a relatively common error. If you slice a string in RPython, you don't want to, you want it to be somewhat fast, so you don't want to check for slicing from the end. And so you, it will refuse to translate slicing to C if it cannot prove that start or stop of a slice are not negative. Right, the test still passed, great. So we reduced the restriction of not having, so let's read the comments. Right, so let's actually, this I want to leave here. And this stuff, right. And now these comments should be distributed through this. Right. Okay. Still seems to pass, that's good. Did I restart? Right, I did restart. So now we're back to waiting for stuff. Yeah, so CPython reduces, CPython is a little bit more general here. So CPython deals with levels greater than 0, then it calls resolve name. And resolve name does things, right? So this is in theory, we can do that, but I'm not really sure that it's so important that we have relative imports within functions fast. The thing that I'm actually more interested in is a relative import, an import with a from list in a function, because I think, like, if you look at right, we do, and PyPy does this all the time. Like, we really have local imports that that have lists of things. And so I kind of wonder whether we want to deal with the from list case at some point. So that's actually, while we wait, we can read the from list code maybe. Right, and there's handle from list. Okay, this comment is not so encouraging. The hell that is from list. Right, we check the, okay, this looks very complicated. Maybe we don't want that after all. Handle from list, what the hell? Oh, it's even recursive. Okay, it does look scary after all. Oh, but it's only recursive if there's a star. Okay. Ah. Right. So maybe we want this fast path, right? From list is not dangerous if it's not a package. If we just say like from math import sin cos, then we ignore all that scary stuff and just say return module. So maybe we can have another fast path in the fast path. Right, but later. Again. Okay, what's going on now? This is too bad. I'm not going to fix that on the stream tonight. I'm actually about to wrap up. So we actually stored something on the space, right? And we do it in a way that's not completely allowed, and we get this very weird error message. Can't modify attribute of a pre-built constant, whatever a pre-built constant is. This is scary stuff. This is scary stuff that I also don't completely understand. So our bootstrapping to C failed, but our test still passed. So I'm now going to commit. Let's look at the diff some more. Right, we clean up the test a bit here to be somewhat nicer. Right. Okay, I'm committing this. Let's check, make sure that I'm on a branch. Right. Actually put in the oops right. Right. Okay. We can push this. Cool. So if there's no questions, I'm going to sort of wrap up soon. The last thing that I want to do is I want to look a little bit at what the, like, I'm waiting for questions. If there are any, please ask them. And the other thing that I want to do while I'm waiting is I'm going to try to figure out what the C code does with the from list. So we have the has from. Right. It does a bit of from list stuff. Like if there's no dot in the name, then it will not do anything. And like this is easy. This would be easy to add. But if there is a dot in the name, that's the front. Then we get the substring and right. Oh no, wait. I'm confused. I mean the not has from. I'm more interested in what happens if we do have a from list. Right. Okay, this makes sense. If we do have a from list, then we check whether we have a path. And if we have a path, then we call back into import lib. But if we don't have a path, then it's easy because it means we're importing from a module, not a package. And then we can just use the module. Great. So this is definitely something that I want to add in our fastpath. So actually, let me write that down as a comment. No, wait. To check that, what's right? Okay. No. Okay. I think that's it from me for tonight. Thanks everybody for joining me. It was a bit of a fighting experience because we had to dig through like 3 variants of the same code: import lib in Python, import.c in like a port of the same thing to C, and then we had to write our own port of the same code to our Python. So that like these 3 versions to look at all of them and keep them in sync was a little bit of an experience, but this was a good first step, and I think I can take this and sort of push it further. I suspect that it will be quite a nice speed up, and I hope that it gets somewhere because it's a real problem in practice. So thanks everyone, and see you next time. Bye. Hi. So this is kind of a video that I recorded the next day, because one thing that frustrates me about the streams, like the recording that you've watched up till now, is that they just end when I run out of time in the evenings and not when I actually like finish something. And so this is 1 day later, and I did some more work on this, and I wanted to just record a couple of sentences about how I finished and what the state of things is now. So let's dive in very briefly. So yesterday I started implementing this importing fast path on the stream, and today I did a number of things. One thing I did is I fixed the bootstrapping to C, and then I lifted one of the restrictions. One of the restrictions we had yesterday was that the from list must be empty. So you cannot say from math import sine cosine. It only works if you say import math, and this restriction is now lifted. There's code down here that says that has, for one of the cases, has another fast path. But that's not so important. The thing that I want to talk about now is the fact that now that the bootstrapping to C works, we can actually evaluate whether the thing that we did here in the stream yesterday actually helps, and I want to briefly do that. And yesterday in the stream we looked at this import bench here, which basically has a function called called smuggler with a local import called import datetime, and then we run this a million times and compute how long that takes, and we compared that on PyPy2 against CPython and PyPy3 and CPython3. So let's do that again. Basically, the baseline was at the beginning of the video. If you say PyPy3 import bench and Python3 import bench, then Python3 is like 10 times faster due to the C-based shortcut that we've been looking at all of yesterday's evening. And if you run the same thing in PyPy2, then it's very frustrating because it's like orders of magnitude faster. Right, and then we did all the work in the stream that you've watched the whole time, and now this morning I fixed it, and now it actually works, and I bootstrap to C. So if I use the new version, which is this one here, and run import bench, then it's actually fast, and that's great. So how does it compare to PyPy2? It's a little bit slower, maybe, but not a lot, and it's definitely a lot faster than both PyPy3 as well as CPython3. We can estimate the speed up. So we've gotten a speed up by a factor of like 228. So that's definitely worth a lot. So now we do a lot better, and we can also compare it against CPython3. Compared to CPython, doing a local import is now 25 times faster. That's also great. So why does that work? And to figure out why it's so much faster, we can look at the JIT code that is being produced when running this thing. Right. So let's open it. Oops, no, not that spell. Right. So this is the trace. This is the intermediate representation of the machine code that's being produced. We've looked at it in the stream a couple of times in the past, and I don't want to like talk a lot about it. But the thing that I want to look into here is this is the trace for main, the main function in the benchmark, and in the main function we have a call function to the smuggler function, which we see here, and then right, and in the smuggler function we have the import name bytecode, and the import name bytecode is now a small number of operations. It's a get field, it's a guard non-null class, and another get field, and those are basically pointer dereferences, and a guard value which checks something, and then another get field and an array read, another get field, and then we check that something's true, we check guard false. And so that's very cheap. That's like, it's a couple of pointer reads, like 1, 2, 3, 4, 5 pointer reads, a couple of compares, and that's not so bad. And this is definitely much better than what we had before, which was calling some Python code, where you need a frame and then you're running the Python code, and you need lots of dict lookups. Notice that there isn't a single dict lookup here. The dict lookup in both sys.modules is completely removed, and the dict lookup in the module dict to check whether we are initializing or not, to read the spec, are removed. So what does the code actually do? So these two instructions read the spec, and this instruction here reads, up till here, we read the underscore initializing field, and this instruction here, these instructions here check that the initializing is set to false. So yeah, this code basically does what we looked at yesterday. In order to be able to know that it's safe to do the importing, we read the spec, and we read the initializing field, and if that is not true, then we can use the module. And that's what you see in the trace here. So maybe we can compare it briefly against what PyPy3 used to do to understand why it's so much better. Right, let's load this. Main, right, smuggler, syntax, right, it's huge, right? We have an import name here, and that starts, and it's basically pages and pages of instructions, and in particular there are lots of allocations here. We initialize lots of objects, and then we do a call assembler, which is basically a call to another piece of machine code, which does all the import lib Python stuff. That takes a lot of time. And then we have, we return from that, and then we read the results, and we can continue. But I mean, alone all these allocations and the call to the other Python code are very expensive. So it's basically not surprising that what we have in the new code is much better. So one last thing that I want to do is let's compare it against what PyPy2 does, right? Because PyPy2 had an equivalent implementation since forever, an equivalent optimization. So this is the trace that PyPy2 produces, and I suspect that, I suspect that PyPy2 is even better, and it is. So PyPy2, the only thing that PyPy2 does, it checks that nobody holds the import lock, and then we're done. And the reason for that is that PyPy2 has a lot more control over how the importing mechanism works, because importing is completely written in RPython. But I think Python 2, like both PyPy as well as CPython, had some weird race conditions if you try to import the same module into different threads, which is one of the nice improvements of import lib. And so it makes sense that we have like a couple of instructions to make sure that no other thread is currently trying to import the same thing. So that sounds like a reasonable, that basically sounds like a reasonable price to pay for better thread safety here. And anyway, it's not like, I mean, the difference isn't huge, right? This could as well be noise. So we would have to do much more careful benchmarking to figure out whether there's really a huge problem between PyPy2 and PyPy3. Right, so I think that's it. I just wanted to record this little coda like conclusion the next day with a bit more extra work. We definitely did most of the hard work in the stream, but I wanted to like to follow up a little bit, like having put another hour or two of work into it. Where is that effort now? The performance definitely looks good, and the plan would be now to run all the tests on the build bots and check for regressions. I kind of hope that there aren't any, and then we can go and just merge this, and it will be part of the next release. Actually, we can even run the first set of tests, maybe. We can run the CPython import lib tests. They're not called this. Ah no, -m, of course. I'm not sure whether they pass on Right. There's some errors here, but I think there's some errors in on the 3.7 branch already, so we didn't make it worse. I would have to check that carefully. And is there still a test imp? There is, and it passes. So this looks quite reasonable, but I'm going to like start the build bots and find out whether there's something seriously broken. Okay, so that's it. I hope you enjoyed that, and see you next time on the stream. Thanks, bye.